So today we're going to cover the last section of chapter 2, section 6. Today we're going to be proving angle pair relationships. We're going to see several theorems and postulates. So the first thing we're going to do, and we talked about this yesterday, is talk about a flowchart proof or a paragraph proof. And again, in this class, we will be only writing 2-column proofs. So just be aware that these other 2 formats exist. And then if you are looking for additional practice problems, you can always look at a question that says to write a flowchart proof and then turn it into a 2-column, or the same thing for a paragraph proof. So a flowchart proof is going to use boxes and arrows to show the logical flow of the argument. Paragraph proof is going to be presenting the statements and reasons of the proof in as sentences, and then they'll put it into a paragraph form. Here is our third theorem of chapter 2, and it's called the right angles congruence theorem. Now again, don't memorize the number, memorize the name or what it states. And the name is almost as long as what it says. So here, the right angles congruence theorem states that all right angles are congruent. Now, when you're putting this in as a reason in your proof, you can do some abbreviations if necessary. So if you wanted to abbreviate the name, maybe you could abbreviate the word right and put just RT. For the word angles, you could put the angle symbol. Then for the word congruence, you could put the congruence symbol. And then you could probably abbreviate theorem as THM. But again, you could rewrite all the words if you choose. Same thing for what it says. You could say all right angles are congruent. Whatever it's going to take maybe to shorten it up, because you're going to be listing this in the reasons of the proof. And they get kind of wordy. So here is an example of a flowchart or a flow proof. So notice they're using arrows and boxes to show how it flows. Everything in the boxes, these would be your statements that are going to go in the first column. And then everything in blue underneath, these are all the reasons. So if you ever are looking for proof practice when you're studying for your test, and there's maybe a question in the homework that is an example of a flow proof, you could always just take the given and the proof and then take all of those boxes and then what's underneath to turn it into that 2-column proof. And that's what we're going to see on the next slide. They're going to take this exact same given and proof and then turn it into the 2-column format versus the flow proof. So here is exactly the same proof, but now in a different format, the 2-column, which is what we're going to be doing throughout the year in this course. So they're asking us to prove the right angles congruence theorem. Now on a test or a quiz, I'm not going to give you a question where I ask you to prove a theorem. Once it's given to you and presented, it's already proven. So I won't ask you to do it on a test, maybe in the homework, but you can now use this theorem. But let's show how they developed the theorem. Now notice they put A, B, C, D. I'm just going to renumber this. Instead of using letters, I'm going to say that this is step 1, 2, 3, and 4. And then I'm going to give the reason for each one of those. And again, don't forget that first one is always your given information. They gave us that angle 1 and 2 are right angles. Then in step 2, showing that the measure of angle 1 and the measure of angle 2 equals 90, this is just the definition of a right angle, and that would be the reason. I'm going to abbreviate the word definition as DEF, and then I'm going to put of right angles. That's step number 2. Then what they did to change from step 2 to 3 is they did a substitution or a transitive. Now, if it's easier, if you were writing this yourself, you could have written step number 2 as the measure of angle 1 equals 90, and then put 90 equals the measure of angle 2. Then when you go to step 3, you can see the transitive a little bit clearer because the 90s merge together or cancel out. And then that's how you can go from 1 equaling to 2, which was step 3. So this is how you could have written it if you were writing it yourself. So step number 3 is transitive, or you could also call this substitution. And what they did was substitute angle 2 for the 90. And then the last step, step number 4, all they did was take away the congruence, the equal sign, and they changed it to a congruent symbol. So that would be just the definition of congruent angles. So DEF is my abbreviation. Instead of writing the word congruent, I'm going to put the symbol, and then I'll say congruent angles. I'll write that in black so it shows up. Now because this theorem has been proven to us, if I would have given you the question on a test, and if I would have said, given that angle 1 and angle 2 are right angles, and if I say prove that angle 1 is congruent to angle 2, instead of doing it in 4 steps, I can now do it in 2. So my proof now that I know this theorem is going to be a column of statements and then a column of reasons. My first step is the given, angle 1 and angle 2 are right angles. That's given. And step number 2 is what I'm trying to prove. Angle 1 congruent to angle 2. And now the reason is this theorem, the right angles congruence theorem.
So you can use theorems as reasons?
Yep. So now that it's been presented to you, you can use them as reasons. So I'm not going to ask you to write a proof for a theorem because it's already been done. The next one is called the congruent supplement theorem. Again, don't memorize the number. This one states that if two angles are supplements to the same angle or to congruent angles, then they are congruent. So the example at the bottom, you're given that 1 and 2 are supplementary and 3 and 2 are supplementary. Because they're both supplementary to angle 2, then I know that 1 and 3 are going to be congruent. Let me add in some numbers so you can see it a little bit better. So let's say I told you that angle 1 was 30. If I know that 1 and 2 are supplementary, if you know that supplementary angles add up to be 180, then I'm going to do 180 minus 30 to get the measure of angle 2. And that's going to give me 150. Now, since 2 and 3 are also supplementary, if 2 is 150, then to get the measure of angle 3, all I have to do is 180 minus 150, and then angle 3 is going to be 30 degrees, which is the same as angle 1. So notice the theorem stated that if they're both supplements to the same angle, they're both supplements to 2, then that makes 1 and 3 congruent. So this next slide has the proof, the 2-column proof for the congruent supplement theorem. So they've already given us the statements. We have to come up with the reasons. So my first statement, always given to me. Angle 1 and 2 are supplements, and 3 and 2 are supplements. Now, if you were writing this and you've already been presented this theorem, we can do it in 2 steps. We could jump all the way down to number 5, and that reason would be the congruent supplement theorem. But we're going to prove this theorem instead. So my next statement, statement number 2, is now showing what supplementary angles mean. That they're the 2 angles, 1 plus 2 equals 180. And 3 plus 2 equals 180. So this is the definition of supplementary. Now we're going to look to see what happened from step 2 to 3. Now, this step is either substitution or transitive. Now, if you were writing this proof yourself, I could take step 2 and I could have written it as the measure of angle 1 plus the measure of angle 2 equals 180. And then the line right below it, I could reverse it and say 180 equals the measure of angle 3 plus the measure of angle 2. And then you can see the transitive a little bit better, that these two 180s cancel, and then you can show that this equals this, which is step number 3. So again, the 180s cancel out here or blend together, and then the two things that are both equal to 180 are also equal. So the reason here is either transitive, or you could also describe it as substitution. Big ideas would prefer the transitive answer. And then now, to go from step 3 to 4, if you notice the difference between those 2 steps, notice what disappeared was the measure of angle 2 from both sides. So they subtracted the measure of angle 2 from both sides, leaving behind angle 1 equals angle 3. So this is the subtraction property of equality. And then lastly, from 4 to 5, all they did was change the equal sign to a congruence. So step number 5 is going to be, and I'll write it down here, is going to be the definition of congruent angles. It's called the congruent complements theorem. So very similar to the previous one, the only difference is now instead of being supplements to each other, they're going to be complements. And remember, complementary angles are 2 angles that add to be 90. So here, if 2 angles are complements to the same angle or to congruent angles, then they are congruent. So same idea here, they're both going to be complementary to the same angle. So here they're both complementary to 2, which would make those 2 angles congruent. So since they're both complementary to 2, then I know that 1 and 3 are going to be congruent. And if you were to write a proof for this, it would be exactly the same as the previous slide, except for adding them and equaling them 180, you would change it and make them add up to equal 90. Now we have a postulate. Again, don't memorize the number. This is the linear pair postulate, which states that if 2 angles form a linear pair, then they are supplementary. So we already saw the definition of a linear pair, and that tells us how they're formed. Now the postulate tells us about the measurement and that they're supplements. So from this picture, I could state that 1 and 2 form a linear pair. So because they're a linear pair, they're supplementary, and when you add them, they equal 180. So the postulate is going to tell us about the measurement. The definition tells us how they're formed. So for the vertical angles definition, we already saw this. This is just telling us how vertical angles are formed. And there are 2 angles such that the sides of one angle are opposite rays to the sides of the other angle. So if I go ahead and trace over the first one and show how angle 2 is formed, and then angle 4, notice their sides are opposite rays. So in this picture, angle 2 is vertical to 4, and also angle 1 is vertical to 3. What we're going to see on the next slide is about their measurement, the theorem. So the definition tells us how they're formed. Know the difference between the definition and the theorem. So our vertical angles congruence theorem, again, don't memorize the number, tells us that vertical angles are congruent. So if in this picture, I told you that the measure of angle 2 was 150 degrees, then the angle that's vertical to that is 4, and it would also be 150. And if I wanted to find the measures of angles 1 and 3, notice 1 and 4 or 1 and 2, those are a linear pair. They're going to be supplements. So if I wanted to find the measure of angle 1, all I have to do is 180 minus 150, and that's going to give me 30, which will also be the measure of angle 3. All right, we are going to be using this theorem a lot. So I've come up with an acronym so you don't have to write out the words vertical angles congruence theorem every time. I'm going to abbreviate this as VAT. You don't have to put VACT, too many letters. So we're just going to call this VAT when we use this as a reason in our proofs. The next slide has this theorem proved in paragraph form. Then the slide that follows that, we're going to take that paragraph proof and turn it into a 2-column proof, just to show you the similarities. So here is the vertical angles congruence theorem presented or proven using the paragraph form. So they've taken all of their statements and reasons and written them as sentences and put them into a paragraph form. However, we will not be writing paragraph proofs. We will be writing 2-column proofs. So I'm going to go ahead now, and we need to come up with all of the reasons for the statements that they provided. So remember, statement number 1, that was given to us. So our reason is given. Then statement number 2, they're talking about 5 and 6 are a linear pair, and 6 and 7. So this is describing that they're a linear pair. So this is the definition of a linear pair. But then in step 3, they're talking about the measurement, that they're supplements. So step 3 is the linear pair postulate. And then now, because they're both supplements to the same angle, notice they're both supplements to 6. So now we can use that newly theorem that we just learned a couple slides ago, and we can say that because they're both supplements to 6, we can say that 5 is congruent to 7 using our congruence supplement theorem. All right, next, they want us to find the value of x. So notice these angles that are pictured here. This is a pair of vertical angles. So I know that angle QPR is going to be congruent to TPS because these are vertical angles. So this is congruent to this. So to find the value of x, I am going to set angle QPR equal to angle TPS. So QPR is 3x plus 1. TPS is 148. And now I need to solve my equation for x. Subtract 1 from both sides. And I get 3x equals 147. Divide by 3. and x equals 49. They didn't ask me to plug anything in. All they wanted was x. One way you could check your answer is you could take what x equals and you could plug it in here for the x. So you could do 3 times 49 plus 1. You get 147 plus 1. If you didn't get 148, you should have recognized that you did something wrong. But the correct answer here is 49. Now we have 3 true, false, and we're finished. First one, classify each statement as true or false. If the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, then A, B, and C are supplementary. True or false? False. Good. Why? What do they have to be? Beautiful. 2 angles. It's got to be. So this is why it is false, because it must be a pair of angles. Can't be 3 angles. So it's got to be a pair. All right, number 2. Vertical angles have the same measure. True or false? We just learned a theorem. True. All vertical angles are congruent, so they have the same measure. So this one is true. Now, for the last one, we need to check their math. They're telling us if angle 1 and 2 are vertical, and the measure of angle 1 is 2x plus 8, and the measure of angle 2 is 3x plus 4, then x must equal 14. Now, there's 2 ways you can go about doing this. You could either plug in the 14 and see if you get the same number, or let's check their calculations and see if they found the right value of x. So what I'm going to do is, since I know that vertical angles are congruent, then I'm going to set 2x plus 8 equal to 3x plus 4. I'm going to solve for x, subtract 2x, or you could subtract the 3x. It doesn't matter which way you do this. Then subtract the 4, and I get x equals 4. Notice they put x equals 14. They did something wrong. So this is false. So the other way you could have done it is you could have taken angle 1, which was 2x plus 8. You could plug in their 14, get 28 plus 2, which gives you 36, and then do the same thing for angle 2, 3x plus 4, and then do 3 times 14 plus 8. If you don't get 36, you know they did something wrong. So this is 42 plus 8. So you actually get 50. So because 50 is not congruent to that, or not equal, then we know that they did something wrong. So that was false.